All right, everybody, what's going on? This video, we're going to learn how to integrate trigonometric integrals. All right, so before we get started, the first thing we need to look at is these rules right here. So if we have sine to the m times cosine to the n, this is what we want to follow. If a power of cosine is odd, we want to say one cosine factor. If power of sine is odd, save one sine factor. And we want to use these properties for each. Sine squared is equal to 1 minus cosine squared, and sine squared is equal to 1 minus cosine squared. And where that comes from, that just comes from sine squared x plus cosine squared x equals 1. And then we just, here we solve for cosine squared. Here we just solve for sine squared. And then if both powers of sine and cosine are even, we want to use these half angle identities from trig. All right. And, depending on if we have sine squared or cosine squared, that's the ones we use. And I'll explain it more while we're working the problem, all of this stuff. And then if we're in the form tangent to the m times secant to the n, and if the power of secant is even, we want to save a factor of secant squared and use secant squared equals 1 plus tangent squared. And look, all these are right here, these are just identities from trig. And then if we have a power of tangent odd, save a factor of secant tangent, and then use tangent squared is equal to secant squared minus 1. And then recall these integrals here. You learned these earlier when you first started learning how to integrate. The antiderivative of tangent is natural log secant, and the antiderivative of secant is natural log of secant plus tangent, and then of course the plus c on the end, the constant. So let's go ahead and get started on our examples. All right, so this first problem here, we want to integrate cosine cubed x. So remember what it said up there, okay? Hopefully you paused the video and wrote all those rules down. Remember, it says if we have a power of cosecant is odd, we want to save a cosine factor. And so we're going to write this as cosine x times cosine squared x dx. See, we just saved one factor of cosine. And then what did it say to do? Use the fact that cosine squared is equal to 1 minus sine squared. So I'm going to take the cosine squared and replace it with 1 minus sine squared. And so that's going to be cosine x times 1 minus sine squared x dx. All right, so now let's look at this. What's going on here? And I'm going to spend a little time explaining it on this problem, because then it applies to all the problems of what we're actually trying to do. Okay, so if you can understand it here, all the other problems are going to make sense. So the reason we're doing this is so we can get to the point of doing U substitution. So you can see, remember, sine squared x, that's the same thing as sine x, all of that squared, right? And you can see inside the parentheses here, inside these parentheses here, we've got sine x. And what's the derivative of sine? It's cosine. And you see how that's out here, this cosine? So I'll be able to use U substitution. Remember, if you have something in parentheses raised to a power, and you let u equal what's in those parentheses and take the derivative, and then it's outside here, remember we can use U substitution, and that's basically what we're trying to get at. Okay? So to do this, I'm going to let u equal sine x, and so du is equal to cosine x dx. And so you can see here the sine x, I'm going to replace that with u, and then the cosine x dx, I'm going to replace with du. So let's see what that gives us. That's going to give us 1 minus u squared times du. Okay, I took the u and I put it in the place of sine. Okay, and remember that sine x, all of that squared, and I replaced the sine x with u. And then the cosine x dx, I replaced all of that with du. All right, so now we just integrate. This is power rule. So what's the antiderivative of 1? That's u. And what about u squared? That's 1/3 u cubed plus c. And then I replace u with what? Well, what's u? U is sine x. So that's sine x minus 1/3 sine cubed x plus c. And there's your answer. And it's really that easy, okay? You've just got to remember this up here, okay? All right, let's look at the next problem. All right, so on this one, I have a power of sine is odd. So I'm going to save a factor of sine. And so that's going to be sine to the 4th x cosine squared x. And then here's that factor I'm saving of sine dx. All right, so look at this. All right, so I've got sine x right here. The derivative of what is sine? Well, we know the derivative of cosine is negative sine, but that's okay if it's negative. We can take care of that. But I've got cosine here, but here I have sine to the 4th. Well, I need to somehow write this sine term in terms of cosine. So I'm going to rewrite this as sine squared x squared. Now, why did I rewrite sine to the 4th as sine squared squared? Well, because I know sine squared is 1 minus cosine squared. Okay, that's how I'm going to get this, right, this term here in terms of cosine. And so that's cosine squared x sine x dx, which that's equal to 1 minus cosine squared x, all of that squared, cosine squared x, sine x dx. All right, now let's use our u substitution. I'm going to let u equal cosine x, so du is negative sine x dx. So see there, that's du. There's sine x dx, but what do I need? I need negative sine x dx. So I'm going to multiply by -1. So that means I need to come outside the integral and multiply by -1. Okay? Because remember, you can't just multiply by something. You got to multiply by 1, and -1 times -1 is +1. All right? And so now let's do our substitution. So in the place of cosine, I'm going to put u. So that's 1 minus u squared squared. times u squared. Okay, I put u in for cosine, put u in for cosine, and then the negative sine dx right here, I'm going to replace that with du. All right, so what is that going to give me? Well, I need to multiply that out. That's going to be 1 minus 2u squared plus u to the 4th times u squared du. Okay, so just remember this part right here, remember that's the same thing as 1 minus u squared times 1 minus u squared, and I just fold it out to get this. And now we're going to distribute the u squared. And so that is going to be u squared minus 2u to the 4th plus u to the 6th du. And now we integrate. So that's gonna be what? 1/3 u cubed minus 2/5 u to the 5th plus 1/7 u to the 7th plus c. And then I'm going to substitute cosine. Oh, and look what I did. I forgot to bring the negative in front. You see that? See this -1, I forgot to write it down. And so this is negative. All that's going to be in parentheses. Now that's one thing. I mean, I don't want to make that mistake, but I'm kind of glad I missed it. I'm kind of glad I didn't write the minus sign. So that would just remind me to point out, make sure that you bring everything down. Okay, just pay attention, take your time, and make sure, don't forget about that negative out there or any number you multiplied by out there. All right, so this is going to give us negative 1/3 cosine cubed x plus 2/5 cosine to the 5th x. I'm plugging cosine back in for u and distributing the negative at the same time. Minus 1/7 cosine to the 7th x plus c. And there's your answer. All right, let's look at our next problem. All right, I got the integral sine squared x dx from 0 to pi. All right, so remember what it said at the beginning. If we have a power is even, I'm going to use those half angle identities. So do you remember? You remember what sine squared equals? Well, let's see. That's 0 to pi. And what was sine squared? It was 1/2 1 minus cosine 2x dx. And what I'm going to do, that 1/2, I'm going to take it and write it outside the integral sign. Okay? All right. And so now we just integrate each one. Well, this one, hopefully to this point you can see, well, you know what the antiderivative cosine 2x is. You can do that in your head, okay? But let's just say that you can't. Let's say you need to use your substitution here. All right, so what we want to do is we want to write this as 1/2 0 to pi times 1 dx minus 1/2 integral 0 to pi cosine 2x dx. All right, so what I want to say first before we start working this is this right here. The antiderivative of this is 1/2 sine 2x. Okay? It's 1 over whatever this number is. Okay? And then sine 2x, because the antiderivative cosine is sine. All right? But let's say we didn't know it was 1/2 sine 2x. So how do we get that? Okay, I'm going to show you how to get it on this one. And then if we encounter it again, I'm not going to do the u substitution. Okay? All right. So for this one, we need to do u equals 2x. So du is 2 dx. All right. So you can see here we've got 2 dx, but we don't have a 2 dx in here. So we need to multiply by 2. So that means I need to come out and multiply by the reciprocal of that. All right. And so this is going to be 1/2 0 to pi of 1 dx minus 1/4. And this is going to be what? Cosine u du. All right. In the place of 2x, I put u. In the place of 2 dx, I put du. All right. Now, since I changed my variable from x's to u's, I also have to change my limits, because see, the limits on this one are in terms of x. Well, I need them in terms of u. Well, what does u equal? Well, u is equal to 2 times 0, which is 0, and u is equal to 2 times pi, which is 2 pi. So what did I do? I took the 0 and the pi, and I plugged it into here to get u. And so this is going to go from 0 to 2 pi. All right, so now let's integrate. So we're going to get 1/2 x from 0 to pi minus 1/4 sine u from 0 to 2 pi. All right. See, we don't change the limits on this one because we're keeping it in terms of x. See, we're keeping this in terms of x, so we don't change the limits on this one. And so this is going to be 1/2 times pi minus 0 minus 1/4 times sine of 2 pi minus sine of 0. Okay. Now, this entire term right here is 0. Because the sine of 2 pi is 0, the sine of 0 is 0, and 0 times 1/4 is 0. And so you can see we're just left with pi over 2. And there's your answer. All right, let's look at the next one. All right, we've got sine to the 4th x. All right, so this is even. The power's even. And it says to use the half angle identities. Well, we know the half angle identity is sine squared x is equal to 1 minus cosine x, or 1/2 times 1 minus cosine x. All right. All right, so let's see what we've got. Well, I don't have sine squared. So this sine to the 4th, I'm going to need to rewrite it as sine squared x squared dx. All right. So this is going to be the integral of what? This is going to be 1/2 times what? 1 minus cosine 2x, all right? And all of that is squared dx, all right? And so this 1/2 here, I want to pull that outside the integral. So that's going to be 1/4 integral 1 minus cosine 2x squared dx. Okay, so where did the 1/4 come from? Well, if you take the 1/2 and pull it out, remember that's 1/2 squared, which is 1/4. So the 1/4 comes out. And now I want to multiply this out. And that's going to be 1 minus 2 cosine 2x plus cosine, plus cosine squared 2x dx. All right, so just remember this part right here. Well, I know that it's just the 1 minus cosine 2x squared. Remember, that is 1 minus cosine 2x times 1 minus cosine 2x. And I just folded out. Okay, that's all I did. All right, so right now we're good to go with this one and this one. Okay, I can integrate both of those. But look at this. I've got an even power on this cosine. So I'm going to have to use that half angle identity for cosine. So that is going to be what? That's going to be 1/4 times the integral 1 minus 2 cosine 2x plus, all right, so now I've got to rewrite this using the half angle identity. So that's going to be 1/2, okay, 1/2 times 1 plus what? Cosine 4x dx. All right, so how in the world did I get that? Well, let's look. So remember, cosine squared x is equal to 1/2 times 1 plus cosine 2x. That's the half angle identity for cosine. So you see the angle here, x? Well, this is twice that angle. This is twice this angle. So I'm converting this, and notice here I've got 2x. So what's 2 times that? That's 4x. All right. And now what I'm going to do, I'm going to go ahead and, I don't know, I guess I will maybe distribute that 1/2 there. Let's do that. So this is going to be 1/4 integral 1 minus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x dx. All right, so we're getting there. Okay, so my next step, I'm going to write 1/4, and then that's going to be 3/2 minus 2 cosine 2x plus 1/2 cosine 4x dx. Okay, so what did I do there? Well, I just did 1 plus 1/2 is 3/2. All right, so now we're ready to integrate. So I'm going to integrate each term. Okay, integrate each term. So that's going to be 1/4 times, that's going to be 3/2 x, all right, minus, now remember what I said here. Remember on the last problem we used u substitution, let u equal 2x, and then du is 2dx. And here we could let u equal 4x, and then du is 4dx. But remember what I told you, whatever that is, we're going to multiply the reciprocal of that. That 2, reciprocal of 2 is 1/2. So 1/2 times 2 is 1, and the antiderivative of cosine is what? Sine. All right. And then I've got plus, what's the reciprocal of 4? 1/4. So 1/4 times 1/2 is 1/8, and antiderivative of cosine is sine. And then don't forget your plus c. And so this is your answer. And yeah, you know, if you wanted to, you could distribute the 1/4. You know, that's up to you or your teacher, whatever they want you to do. Okay, so there we had to use the half angle identities twice. All right, let's look at the next problem. All right, I've got tangent to the 6th, secant to the 4th. So what did it say in all that writing I did up there? Okay, if the power of secant is even, I'm going to save a factor of secant squared. Okay, and so this is going to be tangent to the 6th, x, that's a 6 right there, secant squared x, secant squared x dx. All right. So now, look at this. I've got secant squared here. The derivative of what is secant squared? The derivative of tangent, right? So I want to get everything else in terms of tangent. Well, what do we know about secant squared? Well, we know this is going to be tangent to the 6th x, and secant squared, this secant squared here, that's 1 plus tangent squared x, and then times secant squared x dx. All right, so all I did is I rewrote this secant squared as 1 plus tangent squared. And now let's use u substitution. So u is equal to tangent x, so du is secant squared x dx. So I'm going to replace tangent x with u. So that's u to the 6th times 1 plus u squared. And then look at this. Secant squared dx. Secant squared dx. I'm going to replace that with du. All right, and so now let's distribute this u to the 6th. So that's going to be u to the 6th plus u to the 8th du. And so we're going to get 1/7 u to the 7th plus 1/9 u to the 9th plus c. And then in the place of u, we're going to plug tangent x back in. And so that's going to be 1/7 tangent to the 7th x plus 1/9 tangent to the 9th x plus c. And there's your answer. All right, let's look at the next problem. All right, so we've got tangent to the fifth, secant to the seventh. So what did it say if the power's odd? Let's go back up here. Power of tangent odd, save a factor of secant tangent. All right. So we're going to rewrite this as integral tangent to the fourth, secant to the sixth, times what? Secant theta, tangent theta, d theta. All right. So this is the factor that I saved, secant tangent. Well, the derivative of what is secant tangent? The derivative of secant is secant tangent. So I need to get this tangent in terms of secant. You see that? So this is going to be what? Tangent squared, right? Because I know tangent squared is secant squared minus 1. See, that's what most of these integrals are, is it's rewriting the problem to make it one of those simple formulas we have. Okay? If you've noticed, pretty much mostly what we've used in these problems, look at this one. What do we use here? We use power rule, right? That's the first thing you learned. Integrate. And that's what we're doing. We're changing it to a power rule. You know, some of them we are. And so this is going to give me what? Well, tangent squared is what? That is secant squared minus 1. And then all that squared. I just rewrote tangent squared as secant squared minus 1. And then we got secant to the sixth theta. And then we'll use u substitution. We're going to let u equal secant theta. So du is secant theta, tangent theta, d theta. So in the place of secant, I'm going to put u. And so that's going to be u squared minus 1 squared times u to the sixth. And then, look at this. You see that? I'm going to replace that with du. And then I need to multiply that out. That's going to be u to the fourth minus 2u squared plus 1 times u to the sixth du. Once again, remember, this is just u squared minus 1 times u squared minus 1. And I multiplied it out. All right. So now let's distribute the u to the sixth. So that's going to be u to the 10th minus 2u to the 8th plus u to the 6th du. And now we integrate. And so that's 1 over 11 u to the 11th minus 2/9 u to the 9th plus 1/7 u to the 7th plus c. And then in the place of u, what are we going to put? We're going to put secant theta in the place of u. so that's 1 over 11 secant to the 11th theta minus 2/9 secant to the 9th theta plus 1/7 secant to the 7th theta plus c. And there's your answer. All right, well, let's look at the next one. All right, so problem 7. Well, we got 2 more to work of these, and then we've got another kind of problem to work at the end using some different formulas, so stick around for that. All right, I've got tangent cubed, okay? So remember, the whole point of this is maybe trying to get to where we can use substitution. All right, so let's take a look at that. Maybe use substitution, maybe something else. I don't know, but let's just take a look at this one. So I've got tangent cubed x. So my exponent on tangent is odd. What does it say? Power of tangent odd, save a factor of secant tangent. Save a factor of secant tangent. Well, the problem here is I don't have a secant. I don't have a factor of secant, do I? So let's try this. Let's write this as tangent squared times tangent. All right. And then let's write that tangent squared in terms of secant. So that's going to be what? Secant squared minus 1, okay, that's tangent squared, times tangent x dx. And then let's distribute tangent. So that's going to give me tangent x secant squared minus tangent x dx. Okay, so we can deal with this. What's the derivative of tangent? Secant squared, right? So we can use substitution here. And then this one, what's the antiderivative of tangent? Okay, remember, antiderivative of tangent. Look at there. All right. So let's take this and split it up into 2 integrals. All right, so for this first integral here, I'm going to let u equal tangent x, and so du is secant squared x dx. So see, I can make u substitution here. So that's going to be what? U du. In the place of tangent, I'm going to put u, and in the place of secant squared dx, I'm going to put du. And then that's minus the integral tangent x dx. Now we're ready to integrate. So that's going to be 1/2 u squared minus, and then remember our formula up there, that's natural log secant x plus c. And then in the place of u, what's u? That's tangent x. And so that's 1/2 tangent squared x minus natural log absolute value secant x plus c. And there's my answer. All right. So how about this one? All right, so how about this one? Well, if you remember from the beginning, if you remember the notes, it tells us what to do if the power of secant is even, and it tells us to do what to do if the power of tangent is odd. We don't have any of that. All right. So let's just go ahead and write this as secant x times secant squared x dx. Now, remember, secant squared is 1 plus tangent squared, but I mean, I don't think that's really going to do us any good. Okay, that's not going to do us any good because the derivative of tangent, see, we wouldn't have this term anymore. We would just have this and secant x, and the derivative of tangent is secant squared. So that's not really going to do us, that's probably not going to do us a whole lot of good. So for this one, how about we try integration by parts? All right. So I'm going to let u equal secant x and dv equals secant squared x dx. Because the antiderivative of secant squared, we know that's tangent. Okay, so here we get du is equal to secant x tangent x dx, and v is tangent x. And so that's going to give us what? U times v minus the integral of what? Tangent x times secant x tangent x dx. So it's u times v minus the integral of du times v. All right, so we're going to get what? Secant x tangent x minus the integral of tangent squared x secant x dx. I just multiplied the two tangents together. All right, now let's take this tangent squared and rewrite it in terms of secant. So that's secant x tangent x minus the integral. And what's tangent squared? Well, that's secant squared minus 1 times secant x dx. And then let's distribute this secant x right here. So that's secant x tangent x minus the integral secant cubed x minus secant x dx. All right, so I think I see something going on here. This secant cubed, that looks familiar, doesn't it? See that secant cubed there? So let's do this. Let's write this as secant x tangent x minus secant cubed x minus the integral secant x. Whoop. Forgot to put my dx there, didn't I? All right. So I just split this integral up. And then I know secant x tangent x minus the integral secant cubed x dx. Because I don't know how to integrate secant cubed. That's actually the problem, isn't it? That's the original problem. Minus, and then what's the antiderivative of secant x? Well, remember that formula up there? That's what? Natural log of secant x plus tangent x plus c. All right, so this might look familiar to you. This kind of reminds me of when, if you watch my other video on parts, when we integrated e to the x sine x. So I've got my original problem, this right here, the integral secant cubed x dx. So that gives me secant cubed x dx. The integral secant cubed x dx is equal to this. Secant x tangent x minus the integral secant cubed x dx minus natural log absolute value secant x plus tangent x plus c. And then if I add the integral secant cubed x dx to both sides, that's going to give me 2 integral secant cubed x dx is equal to secant x tangent x minus natural log secant x plus tangent x plus c. And then I just do what? Multiply everything by a half to get rid of that 2. And so that's going to be integral secant cubed x dx is equal to 1/2 secant x tangent x minus 1/2 natural log absolute value secant x tangent x plus c. And there's your answer. All right. So the last type of problem that we're going to work is to evaluate integrals like this. Now, what's the difference in these integrals versus the ones that we did before? Well, if you notice here, see how the angles are different? See, we got mx, nx. See that? The angles aren't the same. So when you come across something like that where the angles aren't the same, we're going to use these formulas right here. See, the angles are different. Well, sine A cosine B is 1/2, and then that's just sine A minus B plus sine of A plus B. All right, so, and I'm not going to go through and read the rest of them for you. I mean, you can read those. It's just the formulas. That's all. You're just changing them. And so let's look at our problem here. See how our angles are different? We got 4x, 5x. So let's apply this first formula here. We got sine, cosine. So we're going to use this. And so this is going to give us 1/2. Okay, so I'm going to write the 1/2 outside the integral. We can pull that 1/2 out. And so that's going to be the sine of 4x minus 5x plus the sine of 4x plus 5x dx. And so that's going to give us 1/2 integral, and that's going to be what? Sine of negative x plus sine of 9x dx. Now, remember your negative angle identities from trig. That's going to be 1/2. And remember, sine of negative x is the same thing as negative sine x plus sine 9x dx. And now we just integrate each one. So that's going to be 1/2 times, and then what's the antiderivative of negative sine? Well, that's cosine. Because remember, the antiderivative of sine is negative cosine. So the antiderivative, and you can look at it like this. The antiderivative of sine is negative cosine, and this negative here make it a positive. And then we have the antiderivative of sine of 9x. Well, remember, we went over this before with the u substitution. That's going to be 1/9, right? So that's 1/9 cosine 9x, but it's what? Negative cosine. Antiderivative of sine is negative cosine. And then plus c. And so this is your answer. And if you wanted to, you could distribute the 1/2. All right, so that was quite a bit there. Okay, there was a lot of problems there that we went through, a lot of examples you saw. So, after watching this video, you should be able to go and do all of them now. You shouldn't have any problems. You saw all the little tricks and everything. So, I hope this video helped. Go check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.